Hi, everyone. Good morning, good afternoon, depending on where you're joining us from today. Thank you for being here for our third session in the Runtime mini webinar series. Today, I'm joined again by Ryan Ehlers, and we are going to talk about how Aqua VShield helps to close the exploitation gap. The problem we are focused on is simple. Security teams are finding vulnerabilities faster than they can fix them, while attackers are exploiting them faster than traditional patch cycles can respond. That gap between exposure and remediation is where VShield comes in. Our goal today is to keep this session focused and practical. I will set up the problem, I'll explain where shift left scanning ends, and then Ryan's going to walk us through a demo. So let's get started. Let's start with what's changed. Security teams, they're not short on tools, they're not short on effort, and they certainly are not short on skilled people. The issue here in the new AI era is speed. The volume of vulnerability findings has grown faster than most teams can realistically triage, prioritize, and fix. What used to be a manageable pipeline has become a continuous and growing backlog. At the same time, the pace of exploitation has changed. Attackers are not operating on human timelines anymore. AI-driven attacks can adapt quickly, they can probe for weaknesses, and they can weaponize vulnerabilities faster than a normal patch cycle can complete. And this is creating a real operational problem. A team may discover a critical vulnerability today, but production remediation still requires engineering time. It still requires change management, regression testing, uptime planning, and then business approval. And with all of that, now we have a gap. On one side, attackers may be able to compromise and expose workload in just minutes, while on the other side, the organization may need days or weeks in order to patch safely. This is what we're referring to as the exploitation gap. And when the response demands entirely on a manual remediation cycle, an organization is already behind. This isn't a tooling problem. This is a structural gap between how fast risk appears and how fast teams can readily respond. Now let's talk about shift left scanning. Shift left scanning is incredibly important. It's a very critical piece of your overall security posture, and it delivers real value for security teams. It helps them to find vulnerabilities earlier. It helps to reduce downtime costs and improve visibility all before an application is deployed. But shift left has a hard boundary. It operates before deployment. It can identify the risk in code, in your images, in your pipelines. But once that vulnerability is running in production, scanning alone will not stop the exploitation. And this is a key distinction that we want to make today. Shift left is helping our teams to find and reduce risk before deployment. But it's the runtime controls that help teams protect workloads after deployment. Both matter, but they're solving different parts of the problem. Once a vulnerability is running inside a container, our organizations have few choices. You can patch, which again may take time, may require some downtime, or you can accept the risk, which may be reasonable given the environment. If it's a test environment, perhaps a little more risk is acceptable. But in a very critical production live business workload, that risk is completely unacceptable. Or the third option is to apply a runtime control that prevents the vulnerability from being exploited while the normal patch process continues. That third option is where VShield fits and what we're going to talk about a little more today. VShield is designed to address the exploitability risk in running workloads without having to wait for that full patch cycle to complete. So it works in a few easy steps. Aqua is going to start with an image scan. So we're going to scan the container image and look to see if we found any vulnerabilities within that scan. When we do identify a vulnerability and when we acknowledge that a VShield is available, the Aqua platform will show that option directly in the UI. And from there, all the security team needs to do is to activate that VShield. And from there, Aqua is going to generate that runtime policy automatically. So this means that teams do not have to manually configure a policy. They don't have to change any code. they don't have to rebuild the image, they don't have to restart the application, and most importantly, they do not need to pull their developers away from their current work just to create this emergency mitigation. Now, teams can decide, again, depending on their environment, how they would like to deploy VShield. So there's two options here, and Ryan will show this in a few minutes. The first is an audit mode. So you can observe the behavior and understand what the potential impact is to your environment before enforcing any policy, or an enforce mode where you can apply that protection immediately. And that means that as soon as the risk is detected, an urgent action happens and that exploit is blocked. This flexibility matters because as we mentioned before, not every vulnerability carries that same business context. So VShield is giving teams that opportunity to make that choice. Now, something that's really important to note as well is what is the goal of VShield, right? What's the point? The goal is not to replace patching. It's very important to understand that patching still matters. Teams still need to remediate that underlying issue. What VShield is doing is it's reducing that risk while that remediation is happening on a realistic time schedule. So we're blocking any of those conditions that the vulnerability would need in order to succeed. Again, that depends on the attack vector, but that might mean restricting access to vulnerable protocols. That could mean restricting access to risky packages or sensitive files, or any capabilities that would allow that exploit to work. An important thing to note as well is this protection is continuously informed by our Aqua Nautilus research team. So as new vulnerabilities and exploits techniques emerge, we're refreshing that VShield library so that teams can apply the most current runtime protections against that real-world attack behavior. So let's talk a little bit about the value. What is the value of a VShield? So VShields are going to help protect those workloads while our organizations continue that process, right? So it's the risk reduction. It's also giving our security teams a way to protect things that they can't see right away, so that workload protection. We're helping to reduce any of these emergency mitigation work for developers. And from a compliance perspective, we're giving teams evidence that a compensating control was in place when a vulnerability was detected. And of course, we're saving time, right? We're eliminating that need for developers to do any type of manual mitigation. It's putting this virtual patch in place so that we can assess the environment appropriately. We can determine the best course of action while we know we're protected from these exploit attempts. So VShield is really this practical next step for teams so that they can identify what's happening, understand if a VShield is available, assess that impact, again, depending on the mode that they want to deploy VShield in. And that's how we're closing that gap. Because we're giving our teams that time and that space to determine what's the best step forward for that vulnerability while knowing that we're protected live in production. So now I've talked about the role that VShield plays, the problem that we're facing in this AI era of exploits. Now Ryan's going to show you what this looks like inside the Aqua platform. And as you watch the demo, there's three quick things to pay attention to. First is how Aqua helps to identify and prioritize vulnerabilities. Next is how to prevent more vulnerable images from entering the environment. And lastly, it's how a VShield can be applied as a runtime control to reduce that risk in the running workloads while patching continues. So with that, Ryan, I will hand it over to you.
And I'm sharing. You can see my screen okay?
Yes, I can see it.
Excellent. So this is, of course, the Aqua console. And we are looking at the vulnerabilities dashboard. So I'll give this demo from the perspective of somebody who's in charge of identifying and remediating vulnerabilities inside of the environment, which many of our jobs are. And what you're seeing up top here, this is Aqua's kind of unique ability to help you prioritize which vulnerabilities to start targeting first. Inside of a large environment, you're going to see thousands and thousands and thousands and thousands of vulnerabilities get detected. We do proof of concepts all the time, where we start scanning images and just a zillion of them show up. Patching a zillion of these images is just not practical, so you need to start to prioritize these things. You need to look which of those available, which of those vulnerabilities out there are actually available to exploit. I mean, you can really take advantage of them inside your environment. How many of those are remotely exploitable, right? Those would be the ones coming in through the front door. And of those that are remotely exploitable, how many of them are actually running inside of your active container? So this screen is going to help you prioritize which things to go after. And of course, you can drill down into any of these. And as you drill down in, it's going to give you a list of all the vulnerabilities, in this case, that are critical, that are inside of that, those final phases of that that map. And so what we see here is we see, all right, these are a bunch of vulnerabilities. They're all critical because we clicked on the red piece. We can see that a lot of these are spring related. And if we look on the left-hand side, we can see that, listen, a lot of these tie back to the exact same CVE, back to that same vulnerability. So, all right, well, what the heck is this CVE? If we click on this, we're going to get the full understanding of what it is and where it lives and who introduced it into the environment. We're going to get a deep dive into exactly what it is by linking back out to the CWE site and say, yeah, this is what it is. This is how you get in. It's some sort of a code injection piece. So, okay, so now we know about what this thing is. So this thing can absolutely be problematic. It's critical. It's running all over my environment. It's spread throughout the things. So I probably want to do three things. I want to take three actions at this point. I want to check on, like Aaron was saying, the supply chain side. I want to make sure that this vulnerability doesn't make it into any new images. That's the first thing I want to do is shut down that pipeline of this vulnerability and make it into my environment. The second is I want to put in some sort of compensating control that says if somebody does do a code injection, they try to move laterally or they try to execute something they're not supposed to, like a reverse shell. We want to be able to shut that down immediately, block that from happening. And the third thing is something called VShield I'm going to show you as the crescendo on this demo. But let me walk you through those two first. So the first thing we're going to want to do is say, hey, listen, I want to make sure that this CVE that's now all over my environment, it doesn't show up anymore from a supply chain side. People who are writing code out there that may be putting this Spring package into their applications and trying to build out images. This hasn't been pushed, haven't been pushed into production yet. I want to create an assurance policy that's actually going to make sure that doesn't happen. So I'm going to go here. I'm going to do an image assurance policy. I could do for Kubernetes or whatever. I'll give it a policy name, a block CVE. I could give the CVE number or whatever it was there. I'll go to here and say CVE blocked. Inside there, I'll just put the CVE number, right? Whatever the CVE number is. And if I hit and move my face out of here. If I hit the save button here, what it will do is it will actually fail this step inside the CI/CD pipeline. So as that code is getting pulled in and starting to get generated into an image, it will block that build from happening. So what we're saying is that we've noticed the CVE that's critical, that's inside our environment, that's something that should not be there. First thing we're going to do is shut down the faucet, right? We don't want any more of this stuff coming into the images. The second thing we'll do is say, let's mitigate the behaviors. I mean, we know that if we have this type of a CVE inside of our environment, first thing we want to do before we try to virtual patch it, before we even patch it and go through the QA cycles and that, is we want to create a runtime policy around those containers. For that runtime policy, we want to say, block drift or whatever it may be, or drop block execution or whatever it is. And you come down here and you say, all right, I want to block for drift. And what's unique about Aqua when it comes to doing things like blocking drifts or blocking container exec or blocking your flawless execution is that we are truly blocking these things. We have all sorts of patterns in place that allow us to do what's called deterministic inline blocking, which means that when you try to execute something, when you try to do something that's malicious that may be tied back to that problematic CVE, we're going to block it from a permission standpoint. We're going to block it at the kernel boundary. The way our competitors operate is that they live in something called the user space. They're monitoring these environments for that user space. Somebody launches a fileless execution. Somebody actually drifts the container. And at that point, they say, oh my God, it's drifted. Let me try and stop that. And they're constantly chasing these CVEs down and the bad actors rather than blocking them at the source. So second thing you're going to do is you're going to set up some sort of compensated control, a real-time block in the enforce mode. So now you've blocked net new CVEs from coming in. You then block the malicious behaviors that a bad actor may take by taking advantage of that CVE. The third thing you're going to want to do is then work with the dev teams and say, hey, listen, so we have identified this nasty CVE, right? It's inside our environment. We can see it. We can see all the images where this thing resides out there. We know its name and the rest, and we know here's all the people that it's impacting. But what we want to do here is say, all right, we have created a compensating control that's going to block any type of malicious action that happens if we're exploited around the CVE. We have set up an assurance policy that makes sure that this CVE is not going to make it into any new image builds out there. But we still have all this stuff running in our production environment. What are we going to do with that? Right? We can't just I'll leave it up to compensating controls. We want to block access to this thing. And like Aaron said, this is where the virtual patching comes in. And we have the capacity around something called VShield to actually block at the package level. So what you notice is first and foremost, a lot of this stuff is grayed out. It's because you can't edit this, right? We these are automated policies based on the specific package. We don't want you stubbing your own toe on this stuff. We know what we're doing. We've created the policies for you. What this policy allows you to do here is say, I want to block this at this jar level, which means that I'm going to block access to this jar. So this is that third step. And the reason it's the third step is because this step typically requires some level of interaction with the application development team. Why is that? Is because what you're going to do here is block real-time access to this jar inside the running container, which means that if this is your critical application that's servicing 50,000 or 100,000 people, and this jar file represents the main logic inside of that application, you are going to shut down the main logic of that application. You probably want to have a conversation with the dev team. Maybe you want to set up a schedule that says, you know what, you got 2 days to fix this. And then we're going to enforce these things. But you need to understand what is the magnitude of impact of actually shutting this piece down. That's why we do this third, because the other pieces are fairly benign. They're blocking malicious activity, they're blocking new vulnerabilities getting into it. What vShield's doing is blocking direct access in real time to this jar inside the running container. So if it's like a log4j and all that jar file is doing is handling logging, or maybe it's some sort of a graphing application and it's only handling the graphing, or some, just some library that somebody pulled in that's not being used, use vShield. Block access to that stuff. Do not allow this to be used. But if this is your production application and you're making $1 million a day off this app, and this jar file is the main jar file that handles that $1 million, now it's a return to risk conversation. Maybe you want to turn on some more compensating controls around your real time. Maybe you want to block more bad behaviors. Whatever it is, you need to have that conversation. But vShield is the capability that we have inside the solution to block access in real time to this jar file inside your running container. So again, if that jar file, if that CVE is so critical that you need to absolutely block access to it inside running environments, you can do that through vShield while you're working on patching this stuff for real. And that's where I'll pause, Aaron.
Perfect. I think we're 1 minute over, but that's okay. Thank you, Ryan, for joining me today. Thank you, everybody, for joining us on VShield. As Mary mentioned, the recording will be shared, and we will see you all next time for our next 20-minute session on July 30th. Thank you so much for joining us. Thank you, Ryan, for the awesome demo as always.
Of course. Thanks.
Bye, guys.